Hi, welcome to the lesson on solving one-step equations. Now, what is an equation? An equation is a mathematical statement consisting of an equal sign. All right, and what is a variable? A variable is a letter that represents an unknown number, whereas a constant is a number that stands on its own. And last but not least, a coefficient is a number in front of a variable, and they're always multiplied by a variable. So let's go ahead and talk about what happens if a variable doesn't have a coefficient or what that means. Well, if a variable does not have a coefficient in front of it, it means that the coefficient is 1. We just don't write 1 because the variable by itself is understood to be 1. So let's take, for example, x plus 7 equals 3. Well, as you can see here, we do not have a 1 right beside this variable, right? So it'll look like this: 1x plus 7 equals 3. Well, you really do not have to write the 1 in front of the variable because it's understood that it's 1, right? So right now you're taking a look and you see that there's only one x here, right? Without actually writing the number 1 in front of it. All right, so that's why you don't need to write this. Okay. All right, so let's go ahead and get started. So let me wipe this out. Let's go to the next slide here. All right, so as you can see here, we have an equation, right? And we have it separated by an equal sign, right? So we have the left side of the equation and we also have the right side. And notice this y is a variable, right? Because it's a letter. And then we have a coefficient of m. Now, why did I choose m here? Well, I wanted you to see that sometimes letters can also be represented as coefficients, right? So if you notice, this coefficient is right beside the variable, right? Or in front of the variable. So we have the coefficient in the variable, and then of course we have the constant. So this b represents the constant, which is usually a number or is a number that stands on its own. All right, so let's go ahead and begin this lesson by solving an equation by addition. All right, so let's say that you're given the equation x minus 6 equals 9. So what you need to understand is that what you do to one side of the equation, you must do to the other side. And we need to ultimately get x alone or isolate x. So in order to do that, we have to undo an operation. So here we have minus 6. So in order to get rid of this minus 6, we need to add 6, right? So we're going to add 6 here, and we're also going to add 6 on the other side. All right, so minus 6 and plus 6 cancels out because it's just 0, right? And so we're left with 1x. X is equal to 15. What you can also do is create a chart here, do and undo, to help you visualize what's going on. So for example, right now in this original equation, you are subtracting 6. So to undo that operation, you have to use the opposite or the inverse, which is addition. Now, how do we know that 15 is the correct solution? Well, you can double check to make sure that your solution is correct by plugging it back into the original equation. So where x is, you are going to replace it with 15. So 15 minus 6 does indeed equal 9. So that means x equals 15 is a true statement. So let's go ahead and solve by subtraction. So let me go ahead and clear this out. All right, so let's say that you're given something like negative 12 plus y equals 8. So the first thing we need to do is isolate the variable y. So we have a negative 12 here. So in order to undo this operation, we must perform the opposite. So the opposite of subtraction is addition. So that means we're going to add 12. And we're also going to add 12 to the other side of the equation. So now we can go ahead and cancel. We're left with 1y equals, and 12 plus 8, or 8 plus 12, is equal to 20. So to double check our work, you know that you can substitute this y for the 20 here in the original equation. So our original equation was negative 12 plus this y is now 20 equals 8. All right, so taking 12 from 20 does equal 8. Okay, so let's go ahead and move on with another example here. So for this example, we're going to solve by multiplication. So let's say that you're given the equation y divided by 8 equals 12. So let's create a chart here, do and undo. So currently you're dividing. So that's what you're doing now. And you need to undo division by multiplication because it's the inverse, right? So let's multiply by 8 on both sides of the equation. These two 8's cancel out. We're left with 1y, which 12 times 8 is 96. So y equals 96. Now let's double check our work. Substitution, 96 divided by 8 equals 12. And as you can see, this does work because 8 times 12 is equal to 96. Let's go with yet another example. So let's solve by using division. So 4 times k equals 128. Let's set up do and undo. We're currently multiplying. To undo that, we need to divide because the goal is to isolate k. So let's divide by 4 on both sides. All right, 4's cancel. We're left with 1k. 128 divided by 4 is equal to 32. Let's check to see if this is the correct solution. So 4 times 32 equals 128. So this does indeed work, or 32 is the correct solution for this equation. So let's go over one last example. What we're going to do here is solve by multiplying the fraction by its reciprocal. So let's say that you're given the fraction 3/5 times z, and it's equal to 15. So let's go ahead and create a do and undo here. So the thing that you have to realize is that in order to get rid of the fraction, we need to make it 1. But how do we do that? Well, multiplying the fraction by its reciprocal will make it 1. So for example, we're multiplying by 3/5 currently. So we'll say multiplying by 3/5. And to undo that, we need to multiply by its reciprocal, which is 5/3. So we're going to multiply by 5/3 here. as well as on the other side of the equation. So if you can see here, multiplying across the numerators, we have 15. Multiplying across the denominators is 15, and 15 divided by 15 is equal to 1, which is what we want. We want 1z, so that's taken care of. So we can just cross these out. So z, let me get rid of this here so it's not in the way. Okay, so like I was saying, z is equal to, and let's simplify 15 times 5/3. So 3 goes into 3 once, 3 goes into 15 5 times. 5 times 5 equals 25. So z equals 25. So what we can now do is substitute to make sure that this solution is correct. So we started off with 3/5. Z is now 25, so 3/5 times 25 is equal to 15. So now let's go ahead and simplify. 5 goes into 5 once. 5 goes into 25 5 times. 3 times 5 is 15. 15 equals 15. So 25 is the correct solution here. So that's all we have for this particular lesson. I hope it was helpful, and I look forward to seeing you in the next video. Take care.